I wanted to go over what I'm calling hot topics for the exam. These are topics that we have gone over, but this particular type of questioning that you're going to see on Hawks is a little bit different than what we did in class, well, on our labs particularly. You have seen these Hawks questions before, but it's something that I didn't really zero in on, and so I wanted to focus on these topics today. There are 4 topics. I have 8 questions, 2 of each topic. So let's get started. Number 1, assume the cost of a taxi is $1 per ride and $2 per mile. Write a function that represents your total cab fare. Well, this is a linear equation, so this is going to be in the form of y equals mx plus b. So I'm going to start there, and then I'll show you how Hawks is going to want your answer. Hawks wants your answer as a function, and we did that in our linear and exponential lab, but again, it's not something that I really spend a lot of time focusing on. So you've got 2 numbers. You've got $1 per ride, and then you've got $2 per mile. This is a little tricky because both of those use the word per. But think about it, $1 per ride. So everybody that sits in the taxi is going to pay $1. That is the starting fare for a taxi ride. Now remember, B is the number at the back. B is your starting number. So every taxi ride starts off at $1. If you just sit in the cab and buckle up the seatbelt, you're out $1. But M is your slope, and M represents the number that changes. This can be an increasing slope or a decreasing slope. It just depends on whether it's going up or going down. But for this particular problem, every mile that you go in that taxi cab, you're paying $2 more, $2 more, $2 more. So that's changing. It's increasing the more miles you ride. So this is going to be our slope. This is our M. And this is our B. So what we would do is we would just plug it into the linear equation. M is 2 and B is 1. Now this is how we would have written it for the most part in the labs and activities that we did. But Hawks wants you to write it in function notation, and we did discuss this. Another thing Hawks is kind of funny about is the variables. So Hawks has decided, since we're talking about cost, and cost starts with a C, they want to use the variable C. So what we will do is we will replace this with function notation. Y is the same as f of C. Again, the reason I'm using C is because Hawks likes C for cost. And then this will be 2, and instead of x, we'll put that C. So this is now our function. It's the same thing that we had in slope-intercept form, but Hawks wants it in function notation. So our function will be f of C. Again, the reason we chose C is because we're talking about cost. And then instead of 2x plus 1, we put 2c plus 1. And this we didn't talk about at all, was domain restrictions. What? If you get in a taxi ride, you have to go a positive number of miles. You cannot go negative miles. You either go 0 miles or more in a taxi. So we have to set this restriction such that C, okay, C are your number of miles, is greater than or equal to 0. And this is the domain restriction that I have seen on all the Hawks questions that I've looked at thus far. So C is greater than or equal to 0. That just means that you either go 0 miles or 1 mile or 2 miles or 3 miles. You can't go negative 8 miles. You can't hop in a cab in New York City and say, hey, I want to go negative 13 miles. It doesn't work that way. Mileage is only positive. Let's move on to number 2. Terry is on a diet. He currently weighs 342 pounds. On his current weight loss plan, he loses an average of 3 pounds per week. Okay, very important here. He weighs 342 pounds right now. That is a positive number. He weighs 342. If he stands on the scales, it's going to say positive 342, not negative. But the guy is losing, key word here, losing an average of 3 pounds per week. So that means that this 3 is going to be a negative number. This is going to be a decreasing slope. Now again, let's write it out in y equals mx plus b form. We know, sorry, my pen is whacking out. Y equals mx plus b. Whoa, that looks really bad. Okay, so we've got y equals, m is our slope, and he's losing 3 pounds. So it will be a negative 3. And then we put our x, and the guy currently weighs a positive 342 pounds. A lot of you on that lab had the negative in the wrong spot. So this is what it would look like on our linear and exponential lab, but Hawks wants that in terms of a function. So let's call this, what would be a good variable? F of W, because we're talking about weight. We're also talking about how many weeks he's on this diet. So let's say F of W equals -3. Instead of X, you're going to put that W, because that's the variable that we've chosen, plus 342. So Y is replaced with function notation. X is replaced with the variable that we chose, and 342 just pulls down. Now make sure this is a negative right there. He's losing 3 pounds per week. So your function notation, again, it has to be written in function notation, is -3W plus 342. Now again, the domain restrictions. W has to be greater than or equal to 0. You cannot be on a diet for a negative number of weeks. This is just saying that your number, your variable, has to be positive. And again, I have yet to see a Hawks problem that did not have, I spelled that wrong, your domain restriction as greater than or equal to 0. I'm not saying it couldn't happen. I'm saying I have not seen it yet. So that's topic 1. That's hot topic number 1. It bounces off of our linear equation lab. We did talk about function notation, but I don't think I assigned you any of those specific problems in Hawks that are exactly like that. It will be on the exam. Let's look at the next topic. The next topic is percent increase and percent decrease. Now, this is something that you struggled with. This was way back in chapter 4, very beginning of class. But no matter if it's percent increase or percent decrease, you use the same formula. Let me write the formula down. You put the amount changed over the original. I'm having a hard time spelling today. Over the original amount. Now that is very, very, very important. You have to read the problem. And then you're going to multiply that to get your percentage. Okay? So let's do number 3. The average price of a certain piano in 1994 was $14,800. In 2014, the average price was $22,200. So first of all, let's figure out how much it changed. $22,200 minus $14,800. That's going to give us our amount change. This is going to go on top. I'm going to get my calculator. 22,200 minus 14,800. These should sound familiar to you. $7,400. That's how much this item has changed. So 7,400 goes on top. We're going to divide that by the original number. You'd have to read the problem and decide which of those numbers was the starting amount for pianos. And we know that because 1994 comes before 2014, then this number right here was our starting amount. 14,800 is how much pianos started out. So that goes on the bottom. Notice that the other number, 22,200, we don't even see it in my formula. We used it, but we don't see it. And then we're going to multiply that by 100. So let's see, 7,400 divided by 14,800 times 100. And that is exactly 50%. This was a 50% increase in the price of that piano. Okay. Now we're going to use the same formula down here in number 4 because we're talking about percent decrease. It's the same formula whether you're increasing or decreasing. So we're talking about a lawnmower here. It was $750 in July, and that following December, so after July comes December, they dropped the price to $500. That makes sense because in December, you're not really needing to cut your grass as much, so they're going to put it on sale. Maybe it was a Christmas sale. So first of all, let's figure out how much this price dropped. It was $750. It is now down to $500. You can put that in your calculator if you want to. But the difference is $250. That's how much the price has changed. So you always put, again, the amount changed goes on top. So 250 goes on top. And the original goes on the bottom. Again, you have to be careful and read. Was the lawnmower originally $750 or was the lawnmower originally $500? Well, originally it was $750. $500 was a Christmas deal. So 750 was the original cost of the lawnmower. And then we will multiply that by 100. So let's see, 250 divided by 750 times 100. We're going to go to one decimal place because typically that's a good stopping point for percentages. So 33.3% price decrease on lawnmowers. All right, let's move right along because I really see how much time I have. Probably not going to get finished with this. Let's try another one though. Let's look at number 5. Suppose you wish to borrow $500 for 16 weeks and the amount of interest you pay is $220 per $100 borrowed. What is the APR? Okay, this is different. Now, I'll be honest, we did not do this exact type of problem, so this is something you really want to tune into. We are looking for the rate. That's what we're trying to figure out. Now, this is a simple interest problem. I hear the word interest, and because I don't have a specific like weekly, monthly, yearly, it's a little confusing because we do have the word week. But this is a simple interest problem. Okay, so you're going to borrow $500. That's what you're going to put in. You're going to put in $500. We do not know our rate, so we're just going to put an R. And we know our time. Time is 16 weeks, but this has to be out of 1 year. And how many weeks are in a year? Well, there are 52 weeks in a year. So we have to convert this to a year's time. So it's going to be 16 divided by 52. That is very, very important. If you just put a 16 down there, you're not going to get the correct answer. And now what we've got to figure out is the interest. It's not that difficult though. You're going to borrow $500 and you have to pay $20 for every $100 borrowed. So think about it. You're going to borrow 100 and then you're going to borrow another 100 and then you're going to borrow another 100, and you're going to do this 5 times because in total you want to borrow $500. This is a 1. In total, you're borrowing $500, and on every 100 that you borrow, you've got to pay $20 in interest. So $20 for this 100, $20 for this 100, $20 here, here, and here. So altogether, this is your interest, 20, 40, 60, 80, 100. So we're going to pay $100 in interest. Now, if you're paying attention, you know there was a quicker way to do that. We could have divided 500 by 100, which is 5, and then we just multiply 5 by 20 and we get 100. So 100 is the amount of interest that you're paying. So 100 goes into the interest position. Now, this is a little bit more complicated to calculate than what we've done in the past. I'm going to put a 1 under this 500, and I'm going to multiply 500 times 16, and then I'm going to divide that by 1 times 52. Okay, so let me put this in my calculator. Here's what I'm doing. I'm typing 500 times 16, and I'm pressing enter. I'm getting 8,000. And then I want to divide that by 52, and I'm getting a big long decimal. So I'm going to have, let me get back to where I was, 100 equals, cannot see, 153.85. And I still have my R over here. I'm trying to calculate the rate. Now, to solve for R, you need to divide both sides by 153.85. So divide both sides by 153.85, and that's going to give us our rate. Now, that is not going to be the final answer, but let me just write down what we get. 100 divided by 53.35. I'm sorry, divided by 153. And I'm going to get 0.652. 0.652. Now that is a rate, but it is not a percentage rate. And if you look up here at the top, we were asked for an annual percentage rate. P is a percent. So we need our rate to be as a percent, not as a decimal. So that's a really easy fix. You're going to multiply this by 100, and the answer will be 64